Hello. So we will be looking at this course today again. You're welcome to this class. The title of the professional course is Failure Modes and Effect Analysis. Some professional will call it cause and effect analysis. Like, this course is basically to help professionals predict failure in a process, in a product, in a manufacturing process, even in a material before it happens. Having a master's degree in material engineering, and also an MBA too, that can correlate it from the engineering perspective and also from the business perspective. In material engineering, when we talk about failure modes, is a predictive mechanism that is used to study the internal molecular structure of an engineering material to determine if it's going to fail upon application of loads. The load could be compressed load or tensive load. So it all depends on how you look at it. But from the business aspect, we're now going to be looking at the quality management system to see how a process can fail if we do not adhere to a particular process or a particular procedure. So we're looking at failure modes generally, how to perform a root cause analysis on possible causes of failure in a process, in a product, and whatsoever. So to provide what this course will do for you as a candidate is that it's going to provide you with the knowledge and practical skills to identify, to evaluate, to prioritize, and eliminate potential failures before they impact customers or business operation. We've seen how failures have impacted massively on industries. We've seen company recalls, automobile company recall vehicles that failed after supply to customers. Millions of dollars lost on recall. We've seen electronic companies in the world recall products because of a particular failure that is synonymous to a particular series of productions they've done. It's massive. It will impact government restrictions, customer confidence will be impeded on that product, and a lot of things will happen. So companies need professionals who can do an analysis, who are certified in FMEA, who understands it and who can help them avert failure before it does occur. Failure mode and effect analysis is a systematic, structured, and preventive risk assessment techniques used to identify possible failure in a product, process, or system before it occurs. We don't want failure to happen. Can you predict that it's going to happen? There was a time when maintenance preventive maintenance was carried out on Tom Miller Bridge, because the level of vibration of the bridge became so much that it was predicted that if structural reinforcement is not done to those bridge, there can be possible collapse. So there are stochastic measures and calculations that can be done in product to know if this company is going to fail, if this product is going to fail. The systematic, the structured, and preventive failure mode effect analysis is more of preventive than corrective. We don't want to correct. We don't even want it to happen at all. The cost of recovery is massive. You may not even recover from the losses that might be incurred when a product, when a process, or when a system fails. So rather than reacting to failure after defect or failure happens, FMEA enable organizations to predict where problems may arise and implement preventive measures earlier before it arises. That is the problem we have in this part of the world. We always would allow things to get worse before we fix them. Have you not seen roads that are bad? And we know those roads can lead to accidents, and accident will lead to death. Yet nobody's going to fix it until people start dying. And say, you see that road, they're not doing. So people already know that these bad roads will lead to accidents. Hence, even before it gets bad, it needs to be fixed. That is the national discussion. But let's bring it back to corporate aspect now. So let's look at introduction to failure modes, which continues key characteristics of what makes a personnel articulate in understanding how to prevent failure. Number one here is proactive rather than reactive. Before it happens, structured risk analysis methodology. You must be able to perform your risk assessment properly on a particular process to know the risk level. We would get to that stage where we're going to be doing risk assessment. Team-based approach, you work together as a team. Yes, and that would help people to see better than an individual who gives the final, becomes the alpha and omega. And when you have a teamwork, what you might not be able to cite can be seen by the other. Focus on prevention instead of correction. We've mentioned that. Improved product quality and process reliability. Everything you must do must be geared towards improving product quality. Your product quality must be consistent. Even if you are going to produce 1,000 units of a particular product, the quality, the strength, the taste, the color, the durability, the flexibility, every characteristic of that product must be consistent. The process must be reliable. Everybody involved in the process, from the first to the last person, must ensure that it is, even down to storage. What about product failure? Product failure does not only happen during production or manufacturing. We've seen products who were properly manufactured and was stored poorly, and because of the bad or poor storage, it failed. In the pharmaceutical industry, for example, even if a retailer is buying a pharmaceutical product, the company will still tell the retailer how to store those products, because failure can happen even outside your outlet. You might sell a product to an outlet. From your outlet, we are done. We have done our part. No, until that product gets to the end user, the final user, you're not done. So you're still going to work with those distributors, those retailers, those wholesalers, to educate them on how to store, on how to display that product to avoid failure. Because if failure does happen, nobody's going to talk. Nobody will blame the retailer. It is the brand that is on that product that would be blamed. So primary goal of this is prevent failure, improve safety, reduce defects, increase customer satisfaction, and lower operational costs. That is the primary goal. Once you're able to implement FMEA, you will prevent failures from happening. You're going to improve safety. Safety is key. For those who are offering health and safety, you will understand that better. Reduce defects, because you have to ensure that your quality assurance is intact. Quality is built in. What it means that it does not just happen. You have to calculate it from the first stage of production to the last stage of production. For example, if you want to cook a particular food, let's say rice, jollof rice, you don't just put all the ingredients at the end of it. You know when to put the Maggi, you know when to add the salt, you know when to add. Everything has timing, quality, quantity. So that is it. So it gives you a final taste, a final color, a final product. And you see some restaurants, whenever you eat from there, the taste of their food is the same, no matter when, where, how. It's the same, because they've been able to prepare a recipe to knowing when to add each per time, the temperature it should be added, the quantity, the quality, how it should be served, how it should be preserved. That eventually gives you the quality. So that's why we say quality is built in. It does not just happen. So to prevent failure, it's a built-in analysis also. So let's look at business value for FMEA. When I say FMEA, you should already know what I mean by that. It means failure mode effect analysis. Everybody needs this. Be you an engineer, a scientist, educationist, we all are engaged with product every day, services, manufacturing. We must have this articulated approach in ensuring that before failure happens, you should be able to smell it and prevent it. Organizations face numerous risks during product design and manufacturing. Without systemic risk analysis, failure can result in customer will complain. Customer will complain. Once there's a failure, there's dissatisfaction. Product recalls. You have to recall those products. Sometimes you have to face sanction. We'll get there. Equipment downtime. When there's failure, what downtime means that the time it takes to shut down production. Downtime. Safety incidents. There will be safety incidents. Financial losses. You can even be company can be sued. Can be sued. There was a time in Nigeria, a case of Pfizer and Kano State. I believe some of us know it. Kano State tested a product, and Pfizer tested a product in Kano State on children. It's called my Pikin also. Yeah, my Pikin. It's actually a product for children. And when they used it on some children, about 100 or 200 of children, about 100 to 200 children died. It's a case, you can Google it, Kano State versus Pfizer. Children died from using that product. Close to 100 to 200 children died in Kano State. They were sued to court and the case is still in court for many years. Has to pay billions of compensation for lives. So no company wants to face this. Is a very terrible issue. When product fails, so company needs you who already have certification to help them ensure you look at the process, you look at the product, and you avert failure from a company. When it happens, damage to company reputation, nobody wants to patronize that organization anymore. You remember the case of Dana Air when there was socialist air crash, Dana Air crash. Nobody would want to fly that line anymore because there will be damage to reputation. So we'll move to the next slide. Benefit of FMEA: reduce product defect, improve customer satisfaction, enhance product reliability, support regulatory compliance, reduce warranty claims, lower maintenance costs, improved communication across departments. These are benefits. You need to communicate. Communication is key. Reduce production defects and reduce warranty. Why do products like electronics and Apple give warranty, 1 year warranty, 2 year warranty? It's just to guarantee to the customer that it's not going to fail. Yeah, even if it fails, bring it back. We're going to fix it for free. So you can see why FMEA is very key here. So, example, a manufacturing company use P, and we're going to talk about P, which is process FMEA, to identify a machine alignment issue before production begins, reducing the risk by 40%. You can use it. We'll talk about that when we are almost there. So at the end of this course, these are the things you are going to know. 1, understand FMEA principles. At the end of this program, this is section 1. We're going to have section 2 and section 3. We are going to be having a 10-paper presentation and a project work to submit to help us further understand the principles of FMEA. It is not just enough for candidates to have certificate alone. You must have the quality to deliver even beyond the certificates. That is what we want. That is what is going to create the opportunity for us, for you in the industry, what you know. So the other you're going to know is explain failure modes and effect, differentiate between DFMEA, PFMEA, and FMEA. Skills you're going to have is conduct FMEA studies, identify risk, evaluate severity, occurrence and detection, calculate risk priority number, RPN. You should be able to do that. Recommend corrective action, lead FMEA team, improve process reliability, integrate FMEA into quality management system. FMEA and quality management system goes hand in hand. That is ISO 9001 2020. I think we now have 2020, 2021, 2022 now. So it goes hand in hand together. Failure, determination before it happens. So at this point, we'll be looking at slide 8, which is let's define FMEA. DFMEA. D, failure on product design before manufacturing begins. That is DFMEA, design FMEA. focuses on product design, not failure, focuses on product design. Before we're talking about the architects, the planners now. Before, why is it that architects and structural engineers are paid even more than the bricklayers? Because they are putting up the conceptual work of the project. They are going to determine failure before failure happens. They will eradicate it from the design. They will design it. That's why you pay them so much, because they are FMEA kind of implementators. Yeah. So purpose of design FMEA is, this design is focuses during design. You are focusing on designer. Where are the issues? Where is it going to happen? And you are eliminating it from the design. Purpose is improve product reliability, eliminate design weakness, improve customer safety. Example, evaluating the braking system of a vehicle through design. You can see this is an engineering aspect now, evaluating the braking system of a vehicle. You have to can evaluate it, right? So if I'm going to give you guys an example, how to evaluate a particular, this is more engineering, so I might want to ask a question that is management, so that it will be easier for everybody to apply. But for engineering students or for engineers who are here, if you are asked, how do you design an HVAC, putting in mind FMEA. HVAC is heating, ventilation, air conditioning system. That's for engineers. But for management, we can make the question simpler. But all is focused at ensuring that whatever system it is, you should be able to analyze it. You should be able to see where failure would occur, and you should be able to eliminate it before it does. So, number 2, we have the PFMEA, process FMEA. Focus on manufacturing and assembly processes. Like we have the plants that processed, like processed industry, like soap making, beverage making, Purpose here is prevent production defects, improved process capabilities, reduce waste. Example is analyzing welding operations, or analyzing a plant simulator. So we have a software called ISIS, Aspen ISIS, that is used for plant design simulator. It helps you to identify in a production plant how production plant can be optimized, how it functions, and you can, with that software, control variables across the plant. We're talking about pressure, we're talking about temperature, we're talking about so many other conditions that control the process of a plant generally. So why is that so? Is to ensure that we can monitor the process, we can control the process, we can avoid failures in that process. So process failure mode effect analysis. We are going to be stopping on the 10th slide today, where we'll continue second section, where we'll be looking detailed into failure modes. You already have this material. I would advise that you read ahead, and then so that when we're coming back, you can easily flow with the class. Failure modes is a little bit technical for non-engineering person, but it's also a course that is cut across everybody, whether you're an engineer, you're a scientist, or you can also get a certification. So system failure mode is the SFMEA. Evaluate interaction amongst multiple subsystems. Talk about the electrical devices, the semiconductors and the conductors. So assess system integration risk, improve overhaul system reliability. So system failure modes have to do with systems. Example, aircraft hydraulic system. We'll be looking at how this example really function practically with the use of FME in some of our next section. So please, you will be sent a link to take the assignment attached to these courses, to this section we have done today. Do well to take the assignment, do well to submit it. It forms part of your grading. Thank you. See you in the next section. Bye.